Hello and welcome to lesson 3 of section 2, where we are answering the question, why build neurotechnology? And this lesson will be answering that with device control, which is something many people are excited about. So when we talk about device control, we're referring to devices in both the medical context and the commercial context. So in the medical context, we listed 3 examples. The first 2 are related to restoring some sort of abilities in patients, right? So when it comes to neuroprosthetics, you're restoring motor abilities that patients have lost in their arms or legs. So the neuroprosthetic is an example of a device, and it's controlled usually using some sort of invasive device. Another example is wheelchairs. On the bottom left, you see a wheelchair that Neurotech and McGill created. It's an EEG-controlled wheelchair. In reality, you wouldn't see wheelchairs being controlled with the EEG because the EEG is very noisy and has low spatial resolution. However, there's a bunch of research being done into how wheelchairs can be controlled with neurotechnology, and there are examples of wheelchairs that are controlled using invasive forms of neurotechnology that have better signal. And lastly, robotic surgeons. This isn't an example of restoring abilities in patients, but it is a way for surgeons to perform surgeries in a quicker, safer manner. So on the bottom, you see an EEG-controlled robotic arm that CMU created in 2019. Once again, you wouldn't see an actual surgery robot being controlled with EEG because EEG is very noisy and has low spatial resolution. So if the surgeon was wearing an EEG cap, their intentions wouldn't be as clear because the EEG signal is so noisy, and you clearly wouldn't want that with a high-risk procedure such as surgery. On the flip side of the coin, we have the commercial context. And when it comes to controlling devices for commercial use, you can really talk about anything that has Wi-Fi or Bluetooth capabilities. Anything that has Wi-Fi or Bluetooth capabilities, you can control with neurotechnology. The only question is how well would it be controlled, right? But in here we've listed 3 examples: personal computers, smart home appliances like the Amazon Echo and your Google Home, and drones. So as neurotechnology advances and we see better non-invasive examples of neurotechnology that have high signal quality, you'll see that these devices will be controlled using neurotechnology. So a more formal way to think about device control in relation to neurotechnology is this idea called the half-life of technology intimacy. This idea comes from Josh Wolf, who is a partner at Lux Capital. Lux Capital has funded many neurotech companies, which we'll talk about later. But essentially this idea is stating that technology is exponentially becoming more intimate with us and our bodies. And this increasing intimacy has implications for how we control devices. So let's walk through this timeline. 70 years ago, we had room-sized computers. So that was the form factor back then. And these computers were operated by researchers only. And the way you would kind of program them, use them, is you would take those wires and plug them out and plug them into different places. So an example of this is the ENIAC, which was the first electronic general-purpose computer. If you've watched the movie Hidden Figures, this is the computer that was featured in that movie. So if you cut 70 in half, 35 years ago, we saw the advent of the desktop. So the desktop was much, much smaller than the ENIAC and could fit in people's homes. The way you controlled desktops was using a keyboard instead of wires. And you'd use your hands to manipulate the keyboard and ask the computer to do what you wanted it to do. So the Apple Macintosh was released in 1984. and it was definitely more intimate than the previous room-sized computers. So you cut 35 in half. 18 years ago, we saw the advent of the laptop. So the laptop was more intimate than the desktop because it was smaller and it combined the computer, keyboard, and mouse. So you could essentially take it with you anywhere you wanted to. And the way you controlled laptops was kind of similar with a keyboard and a mouse. But once again, it was a bit more intimate than the desktop. Cut 18 in half. About 9 years ago, we saw the advent of the iPhone, or the smartphone rather. The iPhone was released in 2007. Now, the smartphone was way more intimate than laptops, right? Our smartphones are pretty much on our bodies at all times. They're really only separated by the fabric of our jeans. And the way we control these devices is also more intuitive. So we swipe, we tap, we pinch. 4 years ago, we saw the advent of smartwatches. The iWatch Series 1 was released in 2015. The iWatch and smartwatches in general are more intimate than smartphones because they're always in contact with your skin. Sometimes you wear them at night. The way you control smartwatches is pretty similar to how you control smartphones. You swipe, you tap, you pinch. But what we're seeing is technology is becoming more intimate. 2 years ago, we saw AirPods. Now these devices are not just in your pockets, they're not just on your wrists, but they're in your ears. So this is very much more intimate than smartphones and smartwatches. And the AirPods 1 were released in 2017. So now the question is, what's next? We went from room-sized computers to desktops to laptops to smartphones to smartwatches to in-ear AirPods. And the question is, what's next? How can we become more intimate than that? And the answer is heads-up displays. So augmented reality glasses and smart contact lenses. There are many companies working on this. Facebook is working on smart glasses, codenamed Orion. Apple is reportedly working on AR headsets and AR glasses. And there's a startup called Mojo Vision that is working on augmented reality contact lenses. So what do I mean by heads-up displays? Heads-up displays are anything you can wear in front of your eyes or on your eyes, and you're essentially viewing the screen without having to, pick up your phone, look at a watch. These screens are pretty much right in front of your eyes. So this is the next step in terms of technology intimacy. However, we haven't tied this yet into what this means for neurotechnology. So we've seen technology become more intimate. However, we need to ask, what does this mean for how we control devices? Right, so how we control these heads-up displays, how will we communicate our intentions with these devices? We can't swipe, we can't tap, we can't pinch anymore. That's a result of the technology becoming more intimate. So there are a few ideas, right? Voice assistants. So we can use your voice to control these devices. And we saw that with Amazon's Echo Frames. You can communicate with the frames and execute commands using your voice. Smart rings. So Apple won a patent recently for a smart ring. And then Amazon has the Echo Loop. But ultimately, the holy grail is thought input computing, so neurotechnology, right? Voice assistants and smart rings are lossy, which means that you can't communicate your intentions perfectly. You have some sort of intention, you have to map it to this sort of middleman, a voice assistant or a smart ring, and then that middleman communicates your intentions to the device. With neurotechnology, we want to get rid of that middleman and go straight from your intentions to the device itself. and here's an obligatory mean. So what we're doing is we're getting rid of the middleman, right? The keyboard and the mouse was the middleman. Voice assistants are kind of still a middleman. Smart rings we haven't really seen being used, but they are also a middleman. We want to get to thought control. So in summary, the third reason to build neurotechnology is to control devices. And device control is useful from both a medical perspective and a commercial perspective. The half-life of technology intimacy from Josh Wolf states that technology is exponentially becoming more intimate with us. And thought input computing is the holy grail of device control because it gets rid of the middleman. There is no voice assistant, there is no keyboard, there is no mouse, there's no ring in the middle of our intentions and the device. In the next lesson, we'll be covering the fourth reason for building neurotechnology, and that is human augmentation.